My name is Dr. Katy Jinkins, and I'm CEO and co-founder of SixLine Semiconductor, where we're focused on leveraging a novel semiconductor material, carbon nanotubes, to meet the needs of next-gen wireless electronics. SixLine is a UW-Madison spinout founded in September of 2022. At SixLine, we overcome a 30-year-old challenge to finally harness carbon nanotubes to meet the fundamental needs of next-gen electronics. While wireless communication is our initial target market, we also will expand into a wider range of semiconductor device markets, such as digital logic or sensors, as the company grows in the future. In the last 2 decades, there has been an exponential increase in the number of wirelessly connected devices, driven by the growth of personal electronics, as well as Internet of Things connected devices. This includes things like creating smart houses and cars, and specifically the Internet of Things market is projected to reach 50 billion devices by 2030. Wireless devices are also required for state-of-the-art military communication, like reliable and long-distance data transmission and highly sensitive radar. As the need for next-gen wireless devices and communication grows, so too do the performance needs. These applications require significant advances in performance, including larger data transmission bandwidths, faster speeds, improved reliability, wider accessibility, and increased energy efficiency. However, current materials cannot meet these requirements for next-gen device performance, and therefore, new material platforms need to be developed. Specifically to achieve this performance, materials for radio frequency, or RF, wireless communication devices must operate at higher frequencies, such as in 6G or 7G frequency ranges, which also allows access to higher bandwidths. In addition, these materials must be able to be integrated directly with computing and logic chips, which have been based on silicon since the early 1950s. However, the current materials that are used for RF or wireless communication, silicon and gallium arsenide, are unable to meet these material requirements. Silicon is cheap and enables direct integration with logic and computing. However, it suffers from comparatively low frequencies. To reach higher frequencies, the RF industry switched from silicon to gallium arsenide as their high-performance RF material. However, due to inherent material and processing differences, gallium arsenide cannot be integrated directly with silicon, and it is also costly. The ideal solution for next-generation RF performance and integration would be if we could achieve high-performance, high-frequency silicon for RF materials. While this is not possible, we can achieve an ideal solution that enables high frequencies, even higher than gallium arsenide, as well as direct integration with silicon-based computing by using aligned carbon nanotubes deposited on silicon. Carbon nanotubes are simply a sheet of carbon atoms arranged in a hexagonal lattice, similar to a chicken wire pattern, that is rolled into a cylinder 50,000 times thinner than a human hair. In SixLine's initial target market of wireless communication, carbon nanotubes enable 3 to 8x higher frequencies than silicon and gallium arsenide and larger data transmission bandwidths. Carbon nanotubes can also be deposited at room temperature, allowing on-chip integration with silicon. Additionally, due to their one-dimensional nature, carbon nanotubes can exhibit high intrinsic data quality and low noise at high frequency, a characteristic that is called linearity, and this is unlike traditional silicon and gallium arsenide. And linearity is truly key for achieving 6G, next-G types of wireless performance. Carbon nanotubes also meet needs of next-gen logic and computing, including up to 1000x lower power consumption. Nanotubes also enable 3D circuits, which provides a route to infinitely extend Moore's law, or increasing the density of devices in a given area, and leads to strong improvements in device performance. Carbon nanotubes also enable up to 100x faster performance in sensors and displays, and the mechanical resilience of carbon nanotubes enables applications of these devices in flexible, bendable, and wearable applications as well. However, to achieve these advances, carbon nanotubes must be organized into arrays consisting of multiple aligned and densely packed nanotubes. Creating these aligned nanotube arrays, however, has been a major challenge since nanotubes were discovered in 1991. This obstacle has involved translating random nanotube soot, which is disorganized and comprised of carbon nanotubes as well as other carbon materials, and sorting out only semiconducting nanotubes of similar diameter. These nanotubes, which again are 50,000 times thinner than a human hair, must then be organized into highly aligned, closely packed arrays. And it has been especially difficult to achieve these arrays using an industry-compatible and scalable process. At SixLine, we overcome this long-standing challenge to produce highly aligned arrays of semiconducting nanotubes using an industry-scalable process. The alignment is within plus or minus 7 degrees, which is sufficient for high-performance wireless communication devices. Our process is compatible with conventional semiconductor device fabrication techniques and produces registered or selectively placed aligned nanotubes, which is needed for the sequential placement and fabrication of commercial devices. The alignment process occurs within seconds, enabling fast device fabrication steps, and at room temperature and pressure, which enables the integration of carbon nanotubes directly on silicon-based logic devices. We have also produced high-performance electronic devices based on our aligned nanotube arrays that outperform silicon and gallium arsenide in terms of their current density and demonstrates the promising performance and capabilities of our technology and our material. Our arrays have a twofold value proposition of both performance and cost. SixLine technology offers the higher frequencies, larger bandwidths, and direct integration with silicon logic chips that is needed for next-gen devices. Additionally, our technology enables production of a drop-in tool for semiconductor fabs, which allows for more direct adoption of our technology. Importantly, we can achieve this higher performance at a 30 to 60% lower manufacturing cost than the current high-performance material, gallium arsenide. This is a cumulative effect from being able to deposit the nanotubes directly on silicon. This enables over a 50% reduction of wafer cost, access to 250% more fab facilities, 50% lower die manufacturing costs due to area scaling of the wafer, and a 65% higher throughput. This value proposition of both performance and cost positions us competitively in the market. Toward delivering this value proposition, we have a strong management and research team. As I introduced myself earlier, I am CEO and co-founder of SixLine, and I co-invented SixLine's core technology during my PhD. My PhD advisor, Mike Arnold, the other co-founder of SixLine, is a world-renowned nanotube expert at UW-Madison and serves as chief technical advisor. Jeff Moore is a part-time advisor to the company and has over 20 years of entrepreneurial and business experience working with startups, including raising $25 million in non-dilutive funding at one of his last startups prior to acquisition. Dominic Bindle serves as a technical and commercial advisor, and in addition to strong technical expertise, has direct experience working with Intel and the semiconductor industry. Padma Gopalan, an expert in nanotube chemistries at UW-Madison and also a co-inventor of the technology, is also a technical advisor to SixLine. Our team will successfully lead our company on SixLine's commercial product path. We will develop and sell 3 separate products as we grow. The first is aligned nanotube wafers, or industry substrates coated with aligned nanotubes. This will accelerate industry transition to our material and allow early adopters to develop integration strategies. We've already demonstrated alignment across a 4-inch wafer and are currently working on 8 and 12-inch wafers right now. We will then develop or work with a partner to co-develop nanotube process equipment. These are tools or equipment that perform our proprietary nanotube alignment processes and integrate directly into fabrication lines. This provides customer flexibility to deposit nanotubes at any point in the device architecture stack during device fabrication. Finally, we will scale up and sell the nanotube materials, or inks, which act as feedstock for the process equipment. These materials will generate consistent and recurring revenue of between 0.5 and 20 million from each customer, depending on number of nanotube layers utilized, and this will be our main product focus long term. This technology and these product paths have large potential markets to address. As I mentioned, our first market will be wafers for wireless RF communication, which is a total market of over $2 billion. We also plan to expand into producing wafers for logic or computing applications further in our company development, which has an $11 billion market. The semiconductor fabrication equipment market is quite large at $120 billion, and we can also potentially pivot into device application markets for RF components or biosensors if we find there isn't enough market share in the wafer markets alone. Toward executing this path, SixLine has already demonstrated strong company and technology traction. The technology is based on 8 years of work and $2 million of research funding at UW-Madison, 5 years of that time was my PhD work, which has aided in significant technology de-risking. We have demonstrated uniform nanotube alignment across a 4-inch wafer, and we see further scaling to 8 or 12-inch sizes to be an addressable engineering problem. Via a previous industrial partner, we have demonstrated state-of-the-art RF device performance that matches the incumbent silicon and gallium arsenide materials, and we have research paths to create devices that exceed this performance. After formation of SixLine in September of 2022, we already have strong engagement with 2 major semiconductor companies, and we are currently finalizing evaluation contracts and agreements. Additionally, this technology is protected by 10 patents, including both process and composition of matter claims, which position us competitively in the market. Here we've included more details on our financial projections and 5-year timeline. Due to the nature of our technology and the longer timeline, we emphasize grant funding in addition to traditional venture and angel funding. Based on cost estimates and projections, we will be able to achieve a healthy 50% margin on product, and we expect to provide our first contract samples to candidate collaborators in 2023. While our product revenue will initially be based on wafers, we will realize equipment sales at the end of 2026, which will substantially increase our product revenue for subsequent years, and we will also expand into the logic market in 2027. Our total CapEx expenses across 5 years of $3 million will enable us to create our own manufacturing and characterization facility and drive the need for funding. Our initial pre-seed round, which we are targeting in mid-2023, utilizing safe or convertible note instruments, will enable hiring an engineer and scientist, device demonstration, scaling alignment, and setting up our own lab or facility. We currently have an exit strategy of acquisition with many potential partners we could work with, whether that's RF or logic device companies, equipment manufacturers, or semiconductor fabrication facilities. Additionally, some of these companies also already perform nanotube-related research, which reduces the barrier for adoption of our material and the ultimate acquisition of our company. To summarize, at SixLine, we produce nanotube materials and films that meet the requirements of next-gen electronic devices and overcomes this long-standing challenge to leverage aligned nanotubes in commercial electronics. We offer a twofold value proposition of both performance and cost, and our technology is protected by a comprehensive IP library. We already have a strong industry engagement, including finalizing evaluation contracts with 2 semiconductor companies. Our current market focus is in wireless communication. However, we plan to expand to other semiconductor device markets in the future. We look forward to expanding SixLine to make carbon-based electronics a reality. Thank you for your time.